Okay, perfect. So like today, what we are doing is like a very like a simple basics of the SPSS. So like what all options actually mean, what variable view we have, what analysis sheet we are getting, and all things. And I will show you some basics of a descriptive analysis, like mean, mode, and all those things. Right? And I will give you a quick revision for the data conversion also, the data transformation. Correct? So let me share my screen once and let me know if it is visible to all of you. Visible to all? Yes or no? So I can't see your chat box now. So if you want, you can have a like a proper talk with me. It's completely fine. Okay, no issue.
Yes, sir,
Yes,
we can see your screen, sir.
perfect. Now let me give you a quick revision for data transformation ones. So let me take some other example now. Age part we have done yesterday. So let me take a hemoglobin level. So in hemoglobin, usually whenever we are doing some sort of analysis, we need to make range that should be like a low, normal or high part. The three things we have for lab data, either it is low, normal or the high part. Done. So I will show you how to make these three groups now. So again, go to transform, go to recode into different variable. Done. Then I will select hemoglobin, transfer hemoglobin to the input variable. Done. Now I need to put a output variable because I'm doing a recode into a different variable. So I should give a new name to a new column. Suppose I'm writing hemoglobin. One more part. Remember hemoglobin. Remember one more part. That is in SPSS. It will not be able to catch a spatial characters, including the space mark also. So what we need to do, we need to use underscore only. We can't even use dash. We have to use underscore. Correct? Let me write category. Then again select Control C and Control V. A simple copy paste part, not a big thing. Correct. Now click on change. Now see, it is showing hemoglobin is changed to hemoglobin category as the output variable, whatever we are making now. Now again, old and new variables. Click on this part. So here, what actually we are getting is the old and new variable. So our old value is what? The continuous data, whatever we are holding, and I need to create a new value now. Now, suppose if I am saying any hemoglobin value ranging from 0, suppose 1 or like 0.2, anything, I can take 0 to suppose 10, not 10, because this is all the liver cirrhosis patient. We might be having all less than 10 only probably. Let me take 8 for the simple example. Okay. So suppose if I am saying if my patient is having hemoglobin up to suppose 7, that will be low. Click to add. Done. Range suppose from 7.10. So why 7.1, not 8? Because we are dealing with some continuous data in which we might be having some sort of decimal. In age, we don't have decimal, even though we have decimal, but for reporting, we ask what is your age? You say 28 or like 29, 30, 24, 23. We never say 24.5, 24.1. Never. Correct? In the case of hemoglobin, we have this type of data. So what we will do, we will write 7.10. And suppose let me take 10. Correct? Suppose this will be a normal. For example, normal. Click on it. Now, any patient having data of suppose 10.1 to suppose 18 will be taken up as a high value. Correct? A high hemoglobin. Click on it. Done. Click on continue. Click on OK. Now see, if I go towards the end, I have that column in the end. See, category, we have 1, 2, 3, 1, 2, 3, 1, 2, 3 for all the variables. Done. If anyhow you are doing some sort of mistake for data transformation, you might be having some sort of blank data also. Done. So always cross check the entire thing, whatever you are getting. Now suppose you forgot like what codes actually I have given, the range part. Like no need to worry. Go back to your analysis sheet. So this will tell you like recode hemoglobin 0 to 7 as 1, 7.1 to 10 as 2, 10.1 through 18 as like 3. Done. So this is how you perform a data transformation. Done. So do we have any doubts now? Anyone? Wait, let me join from my phone also so I can have your chat. Mm, In the meantime, any doubts or questions for me? Anyone? Anyone? Doubts? Questions? Uh, why we use underscore? Underscore why? Because the reason is like this SPSS, Jamu, VR, EZR cannot understand the spatial characters like at, under, like dash, full stop. It cannot follow all the spatial terms. So automatically we need to use underscore. Why underscore now? Let me give a simple example to you. Now, there are two things. Let me remove just for the learning part. Suppose if you are comfortable, you can write hemoglobin get done because you are the analysis part. You understood, okay, this is hemoglobin in the categorical format. If you are giving the sheet, because the analysis part will contain HPCAT in the result part also. Done. So whenever we are sending the analysis sheet to someone just to explain the analysis, they might get confused. Like this is what now? HB cat. I can't follow HB cat. Done. So this is why we write HB underscore and category in that way. Correct? It's completely up to you. Now, for example, suppose if I'm writing in this way, and suppose in this way, if I click on this part, see, variable name contain an illegal character. So automatically SPSS, Jamu, EZR will not be able to follow the special character. That's why we use underscore. Done? Doubts? Questions? Done? Sharmuga? Priya? What about Priya? Yes or no? Confused? Okay, no issue. So the next thing is in the SPSS, the one thing is what we have our data view. The other part is what we have our variable view. Done. In the variable view, we will be having all sort of data, whatever we are holding. Like this part. Wait, this is so much trouble. This Zoom applications. Okay. So let me shift this part to the end. Okay. Now in this part, we are having all the variables, whatever we are holding, like case control, age, gender, etiology, hypertension, DM, all the things, whatever we are holding as a variable part. Now, whenever we are having a data in the continuous format or the numerical format, you might be having a type into the numeric form. Then sometimes we have a variable which cannot be in the numerical part, which will be in the categorical format that will be known as what? A string data. Done. If I take a simple example for gender, gender cannot be in the numerical data like 1, 2, 3, 4. It can be male or female. Then afterwards, if we code, we can change to numerical data. It's completely fine. But gender is what? A categorical data. So it will be in the strings part. Now, if you can appreciate there's three small dots. If I click on this part, this will give me a variable type, whatever we are holding. The most common part in your future also, if you are practicing analysis part, you will be more toward the use of numeric and the string part also. That's it. But comma is like what? At some certain places, we should be reporting data into the comma part, like rupees part, like big numerical data. Whenever we are like having some big like radar data, sometimes we have dots also. Sometimes dot is very important for data interpretation part. Then we have scientific notation. Suppose we're using some sort of symbols, so we can use scientific notation. We have sometimes date, but it's completely useless using of date because date we never require for the analysis part. Then we have a dollar part. So if you are doing some sort of cost of illness or some sort of economic data analysis, you might be having this part as a dollar symbol. The next part is what? A custom currency. So if you want, you can make your own currency tag as well. But again, this will be completely useless for you. Even though suppose if you are doing some sort of analysis in which you are having some sort of economical data, it's completely useless to use because we need to remove all the variables, all the symbols, whatever we are holding. The next part is what? A string data. That is what? A categorical data. Then we have a restricted numerical data in which we are putting a integer. Like multiple zeros will come. Again, not be useful for you at this level. Even though if you are going for the PhD part or some like a research activity, you will be rotating around a numeric part and the string part only. Then other part is completely different. Till in my experience, I have used numeric, comma, dot, scientific notation, and the string part. That's it. Nothing else. Now, the next part, what we have is the width part. The numerical data, whatever you are holding, will have some width like 1, 2, 3. Suppose 0, 1, 2, like 1, 2. It will change. The next part is what? A decimal part. So if you see for the hemoglobin, this is what? A 2 decimal. That means we are having 0.12, 0.14. Let's have a view. So in hemoglobin C, 0.20, 0.69, like 90, 0.90, 0.70, 0.70, 0.20. We might be having 0.22 and like in that way. Done. So automatically if I put 3, it will add one more additional 0 in hemoglobin C, 0.2000, 0.9300. Then if I want, I can decrease also this part. I can change to 1 also. So what will happen? Hemoglobin now 11.2, 6.9, 5.7, 14.7, 11.6. That extra 0 went away. Done. The next part, what we have is the label part, the labeling, whatever we are having. The most important part will be what? A values part. Now, suppose, let me take one simple example for the gender part. Remember, values is a kind of data change, correct? We are doing a data coding part. If I take a gender, if I click on a value part, again, can you all appreciate these three dots? Yes, no? Yes, no? Wait, let me again open your chat box.
Yes,
Can
sir.
you all appreciate? Okay, perfect. So this is what, so if I click on this part, this will give me a values label. Done. So in this values label, suppose, but the most important part, what you should remember, suppose in this part, suppose, okay, suppose if we are having this data, a male, female, you should be remembering what you have written actually. We have capital M, we have capital F. Done. This letter should match in the label part as well. Done. So I will click on this part and suppose by mistake I write a small m. So apart from the small m, all things will be changed because in our data we don't have a small m. What we have capital M. Now let me label as 1. Click on add. Done. So I am saying please code m is equal to 1. Next we have f. Let me write 2. Click on add. That is f is equal to 2. Click on OK. Done. Now missing part is like nothing is missing for as such. The next part, the most important part is what? A measure part. Done. Now the beauty of the application is like what? It will give you all the data, like all the inputs in the form of data visualization. Now if I click on this part, so I request you all to zoom in your screen now to have a proper view. Now the first part is what? A scale part. Done. Scale is like what? A numerical data in which we have a long type of numerical data, like continuous data. Done. That is why we are getting a scale diagram here. Done. The next part is what? A ordinal data. So this is what? Any data which holds some order, like assistant professor, associate, or the professor, or the HOD, or director. Then we might be having suppose school pass, UG, PG, PhD. Then we do have some sort of order. Then the next part is what? A nominal data. So what is nominal? If you see this diagram, it makes very clear to all of us, like even though we are having some sort of categorical data, but there is no order. All are same, correct? So if I take a gender part, correct, it is showing a nominal data. Why? Because gender is what? A type of nominal data, not a data of order. We can't order male, female, correct? So Even though males are different, females are different, but both are same. Like there is no order. That is why it is giving us automatically a nominal data. Then whenever we are having a data type of data in some order, like some rank, like some qualification, like some designation, automatically this will give you a symbol of order like this way. I hope you all can see small, large, and more larger, like a rank part. Then like a UG, PG, PhD.
Yes,
Simple.
sir.
Done. So this is what a variable view looks like. And sometimes what usually happen, so if I take back to you to the main part, so I hope you all can appreciate a small a in front of gender in this part, correct? But it is not present for etiology, hypertension, DM, and like for PSTN, correct? That means during data transformation, some sort of problem has occurred in which coding has not been done properly by the application. That is why it is giving a type of error, correct? Now coming back to our main thing, that is a variable view in which we have put some values. Now, if I click on this part, A1, correct? This is like a highway sign in which if I click on this part, this will change to alphabet. Again, if I click to this part, it will change to numerical data. Now what we have, capital M, small m. If I click on this part, see, it changed to number 1212121212. Done? I hope you all can appreciate. Yes or no? Yes or no?
Yes,
If
sir.
you want, you can give me a quick thumbs up also. I think this will appear on my screen.
Yes, sir.
Done? Okay, fine. So this is how we change. Now the problem comes whenever we are doing some sort of analysis part, this A, small a will be a big trouble for you, a big trouble. So what we can do, we can go to transform. The first thing is what? Always check what is the actual issue. So gender in the string part, it is a type of data in the nominal form. So like all things are proper as per the statistical point of view. So what we can do, we need to correct the error, whatever has occurred during the data transformation or data transfer to SPSS from Excel. So what we can do, go to transform, click on automatic recode, the third option. Then transform automatic recode, select gender, transfer a new name, that is suppose a gender, correct it. Then click on add new name and just click on OK. That's it. So I will just minimize this part, go to the end. Now see, gender corrected is like what? It's not showing a small a now. So this 1122 is like what? Click on again on this part. See, okay. The problem is I have done this coding here, no? This part. That is why it is coming like that part. So, but you just need to remember. Let's see if it is getting corrected or not. Okay, same issue. It will not change now because we have done some labeling before. But you should remember what codes we have given. Correct? Now, suppose male, that is M, it is changed to what? 1. Done? So this is what you need to write very specifically. So like what I always says to my colleague and my junior, like whenever you are doing some sort of data coding, you make your own notes. Like you should be making your notes. Suppose if you all are performing some sort of analysis, make a habit for writing your notes. Even if I do my consultation, for a simple consultation also, I make notes. Then, so this is what a data transformation looks like. Now the next part, the most important part is like what? When we start our analysis part. Now there is one thing, if I can recall my mother's thing, like what my mama like used to tell me. So during her PG, like a long time back, a long time back thing, correct? So she used to tell me, like during our time, we need to take only 20 patients or like 30 patients, that's it, not more than 30 patients. And we need to do manual calculations, like number of male, number of female, average part, median part, all those things at that long back time, correct? But luckily nowadays we have a good analysis softwares because nowadays we are handling a large number of data. This is nothing. How much we are having? 100 patients. I have seen a patient like a 920 patients. I have seen in this Excel we have around 51 variables. I have seen around 480 variables. So like a lot of data will come up whenever we are doing some sort of good analysis part or good data collection. Then so The one way is like what I can sit and okay, I can do some calculation. Okay, how many patients are having alcohol etiology? One, two, three, four, five. Okay, ignore. 5, 6, 7, 8. Ignore. 9, 10, 11, 12. So it will take a lot of time. So what we have done now, we have developed some good of like sort of good applications starting from Excel, but now we have a lot of good applications. So how to perform a simple descriptive analysis, I will show you now. So above we have these options: file, edit, view, data, transform, analyze. This is the most important option for entire SPSS. Then if I go to analysis part, the first part is what? A power analysis. This is what we use for sample calculation. Then just to give you a glimpse, in means we have one sample, paired sample t-test, unpaired sample and unpaired part. For proportion, suppose if I am taking one sample binomial test, this will give me this part. And suppose if I'm taking proportion of 25%, power of 80, okay. So it is found in this part, 0.80. Suppose if I'm taking a power of 80, this will give me a sample. Uh, Power is like what? 0.80. Suppose in my study, we have a 25% prevalence. Click on OK. Now see, this actually gave me a sample. That is, I need a sample of 29 to maintain a power of 80.1%. Done. But again, it's not a useful for you. Coming back to the analysis part, this thing, click on analysis, go to descriptive statistics, click on frequency. Three simple steps. Done. Analyze, descriptive statistics, go to frequency. Because the most important part, whenever you are doing some sort of analysis, this should be your first part because this will help you to identify the missing data or some sort of wrong data. Done. Now, if I click on analyze, descriptive, and frequency, click on this part. Done. That speed is okay today, no? Okay, let me open the chat box. Today our speed is good. Yes or no? Or thumbs up? Okay, yes. Okay, perfect. Okay, perfect. Our speed is good. Perfect. Now suppose, remember, whenever we are having a mixed data, suppose a categorical data and the continuous data, always go once at a time. Then, now the first thing, I want to check only about the categorical data, numbers and frequency. That's it. Click all the data in the categorical format: case control, gender, etiology, hypertension, DM. Let me take some variable of my own interest. Then, but for the analysis part, you need to select all the variables, like whatever we are having, correct? Just click on this part. Done. Transfer. Now, in the last batch, I remember somebody asked, how come you are selecting all together? Because I'm not able to select all in one shot. It's a very simple computer basics, nothing to do. Click on AKI, press Control, click on varices, PAG, JBleed, HE, peptic ulcer, CTP. If you release your control button, click on anything, it went away. Done. A simple computer basics, not big things we are doing as such of now. Remember, the most important part now, we are analyzing a data in the descriptive format now, just for the categorical data. So like no need to touch all these five options, nothing. The most important part is like what? A display frequency table. This is the most important part for categorical variables. Now click on OK. Now see, entire things come up now. So the first table is what? A statistics table. So let me put a big screen like this now. Okay. Now in this part, what actually we are having? Case control. Valid 100. Missing 0. Your missing should always be 0. Done. If you have any missing data, again go back to your Excel and try to correct it. Done. The next part is what? The main analysis part. Case control. Suppose one is case, two is control. So how many case part? 50. So frequency is what? A number part. What is percentage? A percentage part. Done. So 50-50. Okay. Again 50-50. Now the next point is what? A valid percent. Sometimes we have some sort of missing data. So automatically that percentage change will be managed or will be corrected by the valid percentage. Done. But you should not rely on the valid percentage. You should always focus on what? Frequency and percentage part. That's it. The next part is what? A cumulative percent. This is what? Suppose I'm taking 2 plus 4. Okay, 2. Okay, 2. 2 plus 4, 6. Then 6 plus 2, 8. In that way. So here what we have? 50. Then 50 plus 50, 100. Let me take one more example. Suppose 27. This is what? 27, 27. 27 plus 73, that is what? 100. Suppose here we have 100 and 100. This will be what? Then 200 below. Correct? This is what known as the cumulative data. Then what about the etiological part? Suppose one is alcohol. So if I ask you, tell me how many patients are there with the alcohol? Okay, 53 patient. Percentage 53. Done in this way. What about the hypertension? Suppose one is yes, two is no. I'm asking you, I need to know the number of patients with the hypertension. Then 14 patient. Percentage 14%. Done. Doubts? Question? Anyone? Anyone? Do we have any doubts, any questions for me? Anyone? It's like Karthik, it's like completely automatic. Nothing you need to do, nothing. It will automatically manage. That's why, that's the beauty of actually of this application SPSS. And it's very UG-PG friendly. That's why I always suggest if you don't have a background of statistics or data science, you always go with Jamovi or SPSS. No need to touch R, EZR, all the applications. For PhD, of course, I suggest to touch EZR, not R Studio, go for EZR. Done? Others? Doubts, question, anyone? Anyone? It's completely a coding part, Sharmuga Priya. So it's completely coding. Nothing new we are doing, completely coding. The chat GPT, the chat GPT, it's completely based on what? A Python. So if you know Python, so Python is the like a father of all the applications. Your chat GPT, your mobile application, your WhatsApp, your Telegram part, your even the Zoom meeting, all these things based on what? A Python only. See, Nancy, if you are doing a PhD, if you are comfortable, if you need such tables on your screen, then go for Jamovi or the SPSS. I will not suggest you to go for the EZR. So if you are good in numbers and catching the numbers, then you can go for EZR. It's completely fine. Even though Jamovi is completely free to use, as well as EZR, completely free to use, but it will take money to use SPSS. So please cross check with your institution whether they have or not the SPSS version. If they have, then plus point for you. It's completely fine. But if not, you can go for Jamovi. But again, Jamovi is based on what? A R Studio, correct? And R is based on what? A Python. So Python is like a big thing. Then I think Nancy, you were in the last class also, no? Of SPSS, if I'm not wrong, or like some other class of mine. The Noel, the thing is, we do have some other applications also. So if you take SPSS, I think we have PSPP also, something like this. But if I go for the guidelines part, SPSS, Jamovi, R, SAS only we can use. For the big clinical trials, we have to use R and the SAS only, not Jamovi and SPSS, as per the guidelines. But if you are UG, PG, PhD, you can go for the SPSS. It's completely fine. Even though you can go for Jamovi also, it's completely fine. Even though if you can see on my screen, I have this thing, Jamovi, SPSS, Jamovi, G Power, we have this Python, we have this Prism, we have RStudio as well. It depends on my workload. Right? So like this is what we have to do. Can you show how to correct a missing data? Correct what? How to correct like what, Madhu?
Sir, I think if suppose there is a missing data, then what we
Mhm.
should do?
Okay, two important things. The one part is what? Go to your MRD, go to your records, whatever you have collected, and search for the missing data. If you don't have those missing values, consult a statistician to apply the imputation statistics. Now, this is what I will show you. Now, suppose this is my main data. Now, suppose let me remove some random number. Suppose I'm removing this 70. Done. Okay, this is missing now. So, what should I do? I'm not getting this value. It's
Yes, sir.
completely gone case now. Correct?
Yes, sir.
Now,
Suppose,
there is one trick. Huh.
sir, if suppose there is a retrospective data, sometimes we have missing values.
No, 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 no. See, these are completely different things. Correct? Even if you are having a retrospective data prone to have a data loss. Correct? That is the actually a beauty of retrospective data. In retrospective data, this will save you for the publication part because we do have a major concern that is about potential data loss. So what technique I'm going to show you now, this is limited to couple of numbers and should be done by the statistician, not by you all people. Done? Because I hold degree in the statistical part, so I can practice this part, but not you all people. Done? So I'm just showing you a technique. Suppose if you consult some statistician on me for your analysis part, you can tell, okay, I remember this technique. So can we do this technique? Yes or no? Just advice. The problem is whenever we are having a lot of missing data, imputation will give us a single value. Done. That we need to put for all the missing values. Done. So this will not give you the actual value, but this will give you some value nearby to it. Done. Now, suppose this is what age bar. So what I will do, I need to apply the imputation. Remember in very simple terms, whenever we have a data in the numerical format, you need to find the average value of that data. One thing. When we have a data in the categorical format, you need to find data in the categorical part only. That is your number and percentage. Done. Let me take one simple example for age part ones. That is a blank cell. So how to perform the imputation for numerical data? Go to analyze descriptive frequency. Again, a same previous step. Let me reset. I will put age into the variable. Remember, whenever we are having a data in a numerical format, no need for the display frequency table. Click on statistics. Now see, it is giving us all the data. Central tendency, mean, median, mode, sum. Dispersion, standard deviation, variance, range, minimum, maximum, and the standard error means. Done. Then we have distribution also. Kurtosis the skewness. Now coming back to the imputation, we have it in like a numerical format. Click on mean, click on continue, click on OK. Now see, this is what we are getting 53.33. So what I can do, I can replace this missing part as 53.33. Done. Now the question comes, we remember because previously we had 70, now we have 53. So it's a sort of a very big age difference. Yes or no? Yes or no?
Yes, sir.
Correct? So how to define this imputation analysis now? That's how the role comes for the dispersion data. That is what your standard deviation. So again, go to analyze, descriptive, frequency, click on statistics, click on standard deviation, click on continue, click on OK. Now see what we're getting 53 plus minus 12.7. So if I do a simple mathematics, that is what 53.3 plus 12.7. That is what a 66. This is what I'm getting in the plus direction, almost touching the missing value. It was 70. I'm getting how much? 66 point something something. Done. So only 2, 3 number loss we are getting. This is manageable. That is why we always report the standard deviation along with the mean value. Done? Simple? Yes or no?
Yes, sir.
Others? Doubts? Question? But again, I'm suggesting to all of you to not practice imputation in the absence of a statistician. Then you might be having a data loss of 30, 40 patients. You will replace all those blank data with the mean number. That is what 53. Done. So once you have a same data, this will give you a wrong mean. So don't practice imputation without consulting me or any other statistician. Done.
Sir,
It's a
one,
very risky thing. Yes.
sir, one doubt. Standard deviation will be marked as plus.
Plus minus. That's what. So, okay, let me open my calculator also on the screen. Okay, visible to all? Calculator? Yes or no?
Yes, sir. Visible.
Okay. Now plus minus is what? A range part. Whatever we are getting the range, no? That is the range. That is what? What is our mean? 53.3 plus 12.76. How much? 66.06. It's in the positive direction. Then we have minus also, plus minus 53.3 minus how much? 12.7. That is what? 40.6. So I can say, okay, this is my data dispersion from the mean value. So I can say, okay, in my data, it might be a range from 40 to nearby 70. That is what we can say. Okay, but
Okay,
I
sir.
need a number to represent my entire population. That will be what? My mean value. That is what? 53.33. Done?
Yes, sir. Yes.
Okay. Okay. Simple, no? The next part is what? A categorical data. So what to do for data in the categorical format? Apply a simple frequency part. Suppose, let me remove this part. Suppose, let me remove one. I removed one from the etiology part. Now go to analyze, descriptive, frequency. Again reset, etiology, transfer. Remember, this is what a categorical data. No need to touch all these 5 points. Just this much is enough. Click on OK. Now, for the categorical data, what we need to look for, which is the more in number, the more frequency. I think somebody has asked for the what about the valid percentage, how it managed. See, it is missing one, correct? It is one, percentage one, but I can't report this percentage, correct? So we need to report what? This percentage. See, automatically it managed to 100, but for the proper one, it is 99 only. That is what it's how managed. Now, the most frequent number is what? The etiology one, that is alcohol. So what I will do, I will simply replace the missing data with one. That's it. So this is how we perform the imputation analysis. Doubts? Question? Anyone? Karthik, it's depend on the number of sample, whatever you are holding. If you have a sample of 30, I can say, okay, 2, 3 is fine. Okay, 5 is also fine. If you have a sample of 100, I can go up to 10, 15 for you. It's completely fine. But again, it depends upon the data, whatever you are holding and what actually you are looking for the objective as analysis. So we can't take risk. So just for the your sake of knowledge, I'm teaching you the imputation, but don't perform on your own. See, the thing is, the SPSS, Jamovi, or any application, it's like very easy to use. There is no big problem. The problem rely on the knowledge part of the statistic part. Then, so my sir was like my sir, my senior man guide for the statistics. He used to tell, like if you perform a single mistake in the analysis part, it can lead to a death of thousand lakhs of patient. Done. So if you perform a single problem in a OT on the table, only one patient will die. If you perform a wrong analysis, lakhs of patient will die. So you should perform analysis in a proper way. Then because this data will be published, the other researchers will do your thing as well. Like what he or she has done, they will try to follow your research. That is why your method, your analysis part should be very strong. Done? Okay, coming back to our descriptive analysis, again, let me show you the proper way. Go to analyze descriptive statistics frequency. Done. Click on this part. Again, reset. Suppose I'm taking age, all the numerical data I'm taking. Correct? I can take all these variables.
So can you please show reset how you're done?
Here. So
I
reset.
missed. Right, right. Thank you, thank
Okay. Done. Now for the numerical data, always remove this part, not required. It's completely a gone case for the numerical data. Why? Because if I click on this part, if I click on OK, see, this will give me for each part. Okay. Age of 19, only two patients. 25, two patients. 35, two patients. 40, two patients. 44, three patients. 50, two patients. Just all numbers. That's it. So we don't want such data for the numerical part. We want a mean part. So go to this part, remove this click, go to statistics, click on mean, click on standard deviation, and to be on the safer side, click on quartiles. If you remember my first class, I draw one bell-shaped graph, Q3, Q1, Q2. Remember, interquartile range. This is what? A quartile, interquartile range. Done. Click on continue, click on OK. Wait, let me minimize the zoom part. Okay. Now see, the most important principle, all zeros should be zero. Done. I'm happy with this data because all are zero. What about the valid part? It should be the number of samples, whatever you are holding as per the sample calculation. I'm again very happy. Now, what is the mean age? 53.33. What is the standard deviation? 12.76. What about the hemoglobin? The mean hemoglobin, that is 9.98. What about the standard deviation? 2.69. Done. Sometimes what happen, your ST can be more than your mean value. Done. This indicate your data is going into a negative direction. That means, again, let me open my calculator to make it simple. Suppose my hemoglobin is 9.82, my ST is suppose 12. 12 means 9.82 plus 12, that is 21.82. It's too much hemoglobin, not possible as such without any like a malignant condition. Again, 9.82 minus 12, that is what? Minus 2.18. Correct? If you go to some OPD and if you are seeing some patient in your OPD, for example, you will never say your patient, okay, today your hemoglobin is minus 4, minus 2.18. Not practically possible. Correct? Yes or no? Yes or no? Can your hemoglobin be in a negative direction? Like minus 12, minus 10, minus 8, minus 7?
No, sir.
you. No,
Is
sir.
it practically possible? Yes or no?
No.
No? That's how you need to check your data properly. Always check your mean, always check your ST. The other part is what? Always check for data normality. Done? So I will show you how to perform data normality as well. So like whenever you're noticing a lot of ST which are higher than the mean value, two things can be there. The first thing is like what? You can be having the outlier in which suppose I have this hemoglobin, suppose the data here, hemoglobin. Suppose by mistake I wrote 106, 87, suppose 10 like this, right? So this is the outliers and this will cause a lot of trouble to me. So the next part is what? I need to correct this data. 10.7, okay, 8.7, okay, 10.6. Automatically, this will improvise your ST part. But anyhow, if it is correct, your data is completely correct, but your data cannot be in negative direction. So what we can do, report data in the interquartile format. Then if I go back to the internal this part, see 25, 50, 75. 50 is what? Your median, correct? So if I see this part 53, so 53 is what? Your median. So there is a way of writing for this part. 50 bracket open 46 dash, this is what? 63.50. Correct? Now there are two way of writing. 53 bracket open 46 dash the number bracket close. The other way of writing is like what? 53 bracket open 46 comma 63.50. Now I remember in one consultation actually what happened. The faculty asked, we always report in comma, but you are doing in dash part. Why? The thing comes, Whenever we are having some sort of data analysis in which we have data in the negative direction, correct? We have some negative values also for those data. So what actually happened if I write suppose 53 bracket open 46 dash minus 60? This will create a lot of confusion. Uh, in that scenario, we have to use comma. That means 53 bracket open 46 comma minus 60 bracket close. This will make your thing very simple and very clear to understand. Or else what we can do, use a simple dash if you have a data in the positive integers number. That's it. Then anyone, doubts or questions? Anyone?
Very clear.
Anyone? Clear? No? Let me open the chat box also. Okay, this part is done. No, no, no. Okay. Anyone? Doubts? Questions? Anyone? Nirav, which part? The interquartile part. No. Okay, wait. Let me have a clear slide. Hmm. See, suppose, let me open my calculator once. Now see, if my hemoglobin is 10, a mean value, and your ST is plus minus 14. So 10 plus 14, this is the upper way. 10 minus 14, this is the lower way. Minus 4. So I can't say Nirav today your hemoglobin is minus 4. Not practically possible. This is not practical possible. Then minus 4 hemoglobin. So the two things can be there. One thing is what your data might be having some sort of outliers, a big numbers which should not be there. The correction part is correct those number in a simple way. The other thing is what? If data is correct, so what we can do? But my data cannot be in negative direction. So what I need to do? I need to report data in the interquartile format. And that is what? 25, 50, 75. 50 is what? Your median. Correct? So 53 bracket open 46 dash 63.50. This is the way of writing. Done. Suppose if you have a data in the negative numbers. So 53 bracket open 46. If it is a positive, then 46 comma minus 63.50. So this comma will help you to identify the numbers in negative part. If your data is in negative direction or negative sign, no need to use dash. This will create a confusion. So always use comma whenever you are having a negative number. Done, Neerav? Okay. I feel like Dr. Kanchana, Neerav, and one more lady, no? Nancy. I think you were there before also, no? My last class, the last batch,
No, sir, I joined first time, but you are
first
telling
time.
very clearly.
So sorry, what? I can't catch you. Sorry.
Sir, I have joined your class first time this time,
Ah,
and you are telling very clearly, sir. Only thing we have to be little what you call or catch up your speed. That's all.
okay.
It is
Like this is the
you are
very
very nice.
slow I can go actually. This is very
Very
slow what
nice.
we are doing.
No, sir, it is very nice. The explanation is very nice, and you are showing very clearly.
Thank you. Thank you
Excellent,
so much.
excellent, sir.
Thank you. So like you are a professor like what? Or a PG?
Sir, I'm a professor, but I did my PhD after 20 years of gap, so I'm learning everything now.
Ah, okay. No issue. No issue. Completely fine. We should be learning on daily basis. Completely fine. Okay, Nirav is okay. Ah, yes, that's what I was getting confused with this name, Nancy. Okay, okay, done. So, like, this is what it's all about. The simple descriptive analysis part. Then, the other part, what you should know but should not be using is like the data graphs. The same steps, analyze, descriptive, and frequency. In this, we have charts also. So, this will give you a bar chart, pie chart, histograms also. But the thing is, I don't like SPSS graphs. I completely against the using SPSS for this graph. Suppose if I click on bar chart, click on continue, this will give you a so useless graphs. I will show you. Suppose, let me take something simple example. See, see, it's completely useless graphs. If I take some categorical data also, if I remove this part, suppose I am taking this thing, this part, click on OK. See, it's completely a gone case. So, Deepchand, please mute yourself.
Sir, there is a disturbance over there. Sorry.
Yes. So like it's completely a gone case. This graphs I can't use. This is like not that much appealing also. So in my practice, I use Prism. Again, so like a paid software, but it's a nice application for data visualization, and I'm very happy with Prism. Nice graph it will give you. Very nice high pixel graphs. Okay. Or I'm using Jamovi only for the scatter plot because this gives a very nice scatter plot. I'm very happy with Jamovi only for the scatter plot. So sometimes I use Jamovi only for scatter plot. That's it. But it, again, it's on practice to practice. Because in this application also we have graphs. This will give me all type of graphs. Let's see. This will give me bar, favorite, line graph, area plot, like pie, polar part, scatter dot plots. But I don't like SPSS for the graphical presentation. I love this only for the analysis part for UG PG people. That's it. And for PhD people as well. So this is like all about the analysis part. Now let me give you some extra part as well. Now our next class will be more toward the descriptive, compare mean, and the descriptive cross steps. Done. So before going for the analysis part, the main analysis, I will take you some through my iPad, some proper learning, what numbers to catch and what numbers to ignore as well. Because by learning the chi-square, while learning the unpaired sample t-test, you will get a lot of p-values and which number to report is very important. Then I will show you about the Levine test also, what actually Levine test means, and I will show you a data normality also. Done. So we have some couple of minutes, so I will show you a data normality once. This is very, very important before starting the analysis part. Go to analyze, descriptive, and explore part. Done. So let me give you one more thing. So descriptive frequency, let me take some numbers like hemoglobin, HCT, RBC, shift. Click on statistics, click on skewness, click on kurtosis. A simple part. Remember, kurtosis is like a very, very strict teacher. Very strict teacher. If I say zero, that means zero. If you are going towards one, I will make you fail for sure. Done. So kurtosis follow a very strict criteria of exact zero point 0.0. Done. What about skewness? It allow you like a good teacher. So suppose if you are passing with only 2 marks, so he or she will give you extra 2 marks just to make you pass. This is how skewness works. So if your data is up to 0.5, this will allow you to use a parametric test or else no need to use parametric test. Let me show you. Click on this part. Uh, Let me go to chart. Uh, Continue. Okay. Now see, if I just scroll, okay, see, this is the graph. If you can remember the interquartile part or we were discussing about the explore part, the same thing. Done. So see, I can see, okay, this graph is not a proper bell shape. Sometime this is shifting toward the left hand side, correct? What about this part? Even though it looks like a normal data, but it's not a normal data, correct? Now, two things can happen actually. With this graph, some of you tell, okay, it looks like a bell shape in the center. I'm completely happy. I can take this data as a normal distribution. If you come to me as a statistician, I can say, no, I don't trust this part. This might be a not a normal distribution. So same graph can have a two interpretation part as per the experts. Done. So we need to develop some tests which can be globally acceptable, correct? Because in this graph, I'm getting confused whether this is normal or not normal distributed. Suppose if I say this is not in a normal distribution, suppose Dr. Kanchana said it's normal distribution, a big trouble for the students. So what to do now? Which test we have to use? I'm not sure. So what we have done, we have developed a universal diagnosis test for the data distribution. So what we need to perform, go to analyze, descriptive, explore. Simple steps. Analyze, descriptive, explore. Simple step. Remember the most important part, whenever we are having a data in the continuous format, Only those data will be having a distribution. Categorical data will never have a distribution. In a simple word, remember, a numerical data behave like a very small kid. How small kid runs here and there, correct? So what we do, we just tie them up at a single place. You just stay there. That's it. That is how we are treating our numbers also. So if you love number, you will treat number like a small kid. So you know that numbers are like a very notorious kid. So they will run here and there. So you should know how to handle them. So again, click on plot, click on normality plots with test, simple test. Done. Click on continue. What I have done, I just took three random continuous variable, but for the analysis part, we take all continuous data. Done. Select, go to plots, click on normality plots with test part, click on continue, click on OK. Done. This is running. So see, this is the QQ plot. So in the center line, all the data, all this small dot should be on this black line only. It should not be above, below. If it is above, below, that means some data is here and there. Now see this part. It's a center line, but see a lot of random distribution. Data are not normally distributed. So if you want, you can ignore all this graph, directly come to the test part. That test table is where? Here. The test for normality part. Then the one test is what? Kolmogorov-Shimrow test. The other part is what? A Shiproville test. If you have a data or sample of data up to 50 patients, up to 50 your sample size, use a Shiproville test. If your data is more than 50, use a Kolmogorov test. Then in a scenario, what we are having a data of more than 50. Correct? So what I will do, I will take a Kolmogorov test. Now if it is coming significant, like less than 0.05, which indicate your data is not equally distributed, you have to go with the non-parametric test. Then it is what? 0.133, 0.200, 0.200. That means hemoglobin, HCT, RBC behave like a good kid. This is normally distributed. So we can go with what? A normal parametric analysis part, like unpaired sample t-test, ANOVA, unpaired sample t-test, all those things. Done. There is one scenario. Suppose, let me take all this data and let's see how it behaves. Because this is the most common problem what you will face afterwards. Let me take all random data. Let me take more numbers also. This part. Okay. I will remove this part. Go to plots. Click on this tick part. Continue. Okay. Okay. It's taking time. Turning examination part. Okay. Now, where is my test for normality? Let me remove this table. See, here, test for normality. Now, the best example I'm showing you. Hemoglobin 0.133, HCT 0.200, RBC 0.200. That means the three variables are stable. What about MCV? Less than 0.001. That is not significant. Sorry, significant, which means MCV is not a stable data at which we have to use a non-parametric test. What about MCH? Stable. This part, stable. What about PLT count? Significant. Above variable, significant. PCT, significant. So I can say, okay, I'm getting 50% stable, 50% not stable. In such scenario, what you will do, blindly go with the non-parametric test. Mann-Whitney test, Wilcoxon test, Friedman test, and that sign test. Done. Whenever you are having a confusion, what should I do? Directly apply what? A non-parametric test. Then, if it is all non-significant, go with what? A parametric test. If any number is coming significant, apply non-parametric test. Then, doubts, confusion, anyone?
Sir, you told non-parametric man-Whitney test, Wilcoxon and
Friedman sign test. There are
okay.
lot of tests. Ma'am, I will show you like all the tests. So from tomorrow, ma'am, we are starting with the parametric test, like t-test, unpaired sample t-test, all those things. Then I will show you non-parametric test also.
Okay, sir.
So
Thank
like
you.
if somebody asks how you decided on the Mann-Whitney, this is the answer. Test of normality. Others? Doubts, questions? Anyone? Anyone? Doubts? Question? No one? When we need to know, whenever you are like having a data in a numerical format, apply a test for normality. Don't run any analysis in the continuous format without checking the data, normality part. Now, the thing is, whenever we are having a data in the continuous format, see, this is I'm saying again, don't take statistics in a very simple way. If you have a doubt, consult the statistician. There is no harm in consulting. Then if you are doing some sort of wrong analysis part, then this can put you in the blacklist. Your paper can get retracted. Why? Because the journals, even now also, I am getting paper just to cross check the method and the analysis part. Remember, to make it very simple for you, remember one simple thing. Suppose you wrote a nice paper for a cardiology. Out of 10 reviewers, 9 are very expert in the field of cardiology, all doctors, and one is what? A statistician. All 9 doctors say your paper is too good, awesome paper, awesome outcomes, awesome this thing, that thing. If I say as a statistician, I don't believe your data, I found some trouble in your data, this should not be performed, that should be performed. Your data normality was not evaluated. Why you applied when Whitney U test, not paired sample t test, or that's like unpaired sample t test? Why there is no odd ratio? Why we have this part, that part? Your paper will get rejected because of my comments. Even though 9 doctors said it's very nice to go, but my comments were against you, your paper will get rejected. Then, even sometimes as a statistician part for me, I get sometimes to write a letter to editor also, in which I need to focus mainly on the result part and the method section, mainly focusing on the statistical analysis point of view. So I will share my paper once with you. Just now, I think last month, I published one paper that is letter to editor in the Scopus index only. So I wrote 4 big comments only with respect to method and the analysis part. My paper got published, but a big trouble for the authors who did some research work. But even though there is no impact on the retraction path, it's completely fine. It's all a learning phase. But you should be very strong for method and the result part. Only then you will get a request from the editor to write the letter to editor for some topics. See, uh, Farzin, this is not a simple thing, correct? In your PharmD, your thesis will come in the coming last years. You need to find your sample size. You need to find your protocol. You will do some data collection, data cleaning, your data analysis part, data interpretation part, writing part. Your thesis will come, no? So in your thesis, you will be doing all the same steps, what I'm going to teach you. So don't take statistics in a very simple way. Then so always consult a statistician if you have any doubt. There is no harm. Graph pad is different. This is different. Okay. Others, doubts, question. See, you have my number in your WhatsApp group. So if you want, you can have like a personal message with me as well. If you have any doubts or like any doubts, it's completely fine. I will help you. No issue. So I'm in your group also. You can directly message me. It's completely fine. Done? Doubts? Any questions? Any doubts for me now? Or can we wind up? Okay, then I think we can wind up now. So thank you so much, everyone.
Thank you, sir.
Good evening, sir.
Yes, ma'am. Yes, ma'am.
Yeah, sir. Actually, I don't know that today is the class. The class schedule is generally for Thursdays, no, sir.
No, ma'am. Like 2 weeks before, I put a WhatsApp message, ma'am. Like this will be from 12 every day at 7:30. Because
Okay,
now that
okay.
SPSS principle has changed, they are allowing only for the 2 week free trial. So if I take
Oh,
class only on Thursday, then you all can't practice. So I want you all to practice. So that's why I'm keeping class on daily basis at 7:30.
okay, okay, sir. So from now onwards, daily only by
Yes,
7:30.
ma'am. Daily at 7:30 p.m., ma'am.
Okay, sir. Thank you. And when can I get this recording, sir? Why? Because I don't know regarding that. That's
Ma'am,
why I
it's
bit late.
completely clear my part, ma'am. So I think we have Samriddhi in the class. So I think she will take over this comment, ma'am. So usually
Okay.
within 24 hours, they will share the recording part, ma'am. It's completely
Yeah,
fine.
like I just want to complete before the commencement of upcoming class. No, so that's what.
Okay.
Yeah.
Okay, ma'am.
Okay.
So,
Thank
ma'am,
you.
in the sense, in a very simple way, ma'am. So none of our class will be interconnected, ma'am, because we're doing some sort of
Okay.
analysis part, ma'am. So if you want, you
Okay.
can watch the class afterwards also, because
Oh,
tomorrow we are doing like suppose unpaired sample or like the paired sample t-test, which is completely different from the
fine,
man-Whitney
sir.
or Wilcoxon test.
Okay. Okay, sir. Fine. Thank you. Thank you,
Okay.
sir.
So like usually, ma'am, within 24 hours, like they will update the playlist, ma'am.
Okay, sir. Thank you.
Okay, ma'am.
Thank you, sir.
Sir, one request, sir. Can
Yes, ma'am.
Are you going to teach about the sample size calculation also, sir?
Ma'am, it's a very broad topic, ma'am. So in a very
Okay.
simple way, if I say I have a book for samples I can share with you. So it's a book of like I think 550 pages, multiple
Oh,
formulas,
God.
ma'am. The
Okay.
problem with the sample is like what, ma'am?
So
Whenever
better,
we are, ma'am,
sir, better we should go with the statistician help for
for
sample size
sample calculation,
calculation.
ma'am, because in my
Yes.
first class also I told the entire class,
Yeah.
like if you are a consulting statistician as a part-time, it's fine to go, or else you should be having a good amount of sample calculation experience because even in the big pharma industries, ma'am, statistician with experience of more than 5 years, they also scared to perform a sample calculation. So
Okay, sir.
people who
We'll
have a
go
lot
for the
of experience,
statistician. Which
that's
is,
what, ma'am.
yeah. Thank you, sir.
So if you want, you can message, ma'am. I will help you. It's completely fine.
Okay, sir.
So it's just like a 30 minutes work for us for doing a sample calculation. The
Okay, sir.
thing, it's a note for all of you, for the class PG people and UG people and the faculties also. Suppose if I am saying I am taking all liver patients, I will do a 2 time follow-up and I will collect this sort of patients. I have a different formula, different calculation for your scenario. Suppose in the next class you tell, sir, all things are same, but I will take only 1 time follow-up now. Again, my formula will change, my numbers will change, your sample will change. So during the sample calculation, your single statement can change the formula and the calculation part. So it's a very like a dangerous process in a very simple way. So ma'am, you please consult a statistician for sample calculation.
Okay, sir. Thank you very much.
Okay. Okay. So I think we can wind up now. Thank you so much, everyone.
Thank you, sir.